In 10.4, we're learning about geometric series that have an infinite number of terms. More specifically, we're going to be finding the sums of these kind of series. So a common misconception is that if you add up the terms of a infinite geometric series, that it'll go to infinity every time. That's not the case. So for example, let's say this right here is a candy bar. And on the first day, you eat half of your candy bar. Then on the second day, so let's say you've already eaten this. And then on the second day, you eat half of what's left. So you ate half of it, and then you ate a quarter of it. And then after that, you eat half of what's left. So then you're eating 1/8 of it. And then the next day, you eat half of what's left. So you're eating that part. You're eating 1/16 of it. If you keep eating half of what's left, this series will never end because you'll never finish it. But what will all this add up to? Well, we know what it'll add up to because eventually you're going to get really close to finishing that whole candy bar. So this should eventually equal 1. So the formula for that is you take the first term, so I'm following this formula here. You take the first term, that's your numerator, and you divide by 1 minus, and r is the common ratio. So the way you find r, you just take any value and divide by the value preceding it. So 1/4 divided by 1/2 is the same as 1/4 times 2. 1/4 times 2 equals 1/2. So 1 minus 1/2. You end up with 1/2 over 1/2, which equals 1. So this formula only works when r is between -1 and 1, not inclusive. So if the absolute value of r is greater than or equal to 1, it does not have a sum. It'll just go to infinity. So first thing you should do is find r. For this problem, r equals 3 over 2, which equals 1.5. That has an absolute value bigger than 1, so this series has no sum. Okay, on number 2, it's easy to find r when it's in exponential form. R will just be the base. So on number 2, the base is -1/3. That's your r value. So on number 2, r equals -1/3. We know that that satisfies the condition of being between -1 and 1. So we could find the sum. The sum will equal a1. So if we plug in 1 here, we will end up with 48. Because it will be -1/3 to the 0 power, which is 1, times 48. So a1 is 48 over 1 minus -1/3. So it's 48. 48 divided by 4 over 3 is the same as 48 times 3 over 4, which is 36. Okay, for number 3. first find r. So the way to find r, take any term except for the first term and divide by the term before it. So dividing by 2/9 is the same as multiplying by 9/2. So I'm going to reduce. That will equal 3, 1. So this becomes 5/6. That is between -1 and 1. So this will have a sum. S equals A1 is 2/9 over 1 minus R. 2/9 divided by 1/6 is the same as 2/9 times 6/1. So 12/9 equals 4/3. Okay, for number 4, it is in exponential form. We could tell it's infinite because it starts at 1 and goes to infinity. So we can do S equals A1 is going to be 22. If you plug in 1 for k, the exponent becomes 0. -1 to the 0 is 1. So it'll be -1/2 to the 0 power, which is 1. 22 times 1 is 22. So it's 22 over 1 minus, and r is whatever the base is, whatever has an exponent. So r is -1/2. 22, 1 minus -1/2 is 3/2. So this becomes 22 times 2/3, which equals 44/3. All right, repeating decimals are infinite geometric series. Well, the sum of an infinite geometric series, but I'm going to show you a shortcut for these. So anytime you have 2 digits repeating, the fraction is just those 2 digits over 99. If you had 1 digit repeating, it would just be that 1 digit over 9. So if you had 0.11111 and the ones kept going forever, that would be 1/9. You can verify this using a calculator, but you're supposed to do these problems without a calculator. So we're going to reduce 42/99. 3 goes into both, top and bottom. So 14/33. 14 factored is 2 times 7. Neither 2 nor 7 goes into 33, so this is reduced. Okay, number 6 is equivalent to 0.5 plus 0.024. So breaking that up, we know that 0.5 is 1/2. All right. For the second part, I said that if 2 digits repeat, it is over 99. But that would only work if we wanted 0.24 repeating. That's not what we want. We want 0.024 repeating. So to move the decimal place 1 spot to the left, I need to add a 0 here. Okay, now I'm going to reduce. Let's see, I know that 3 goes into top and bottom, so I'm going to divide top and bottom by 3. 8 over 330. Looks like I could still divide by 2. Can I divide by 4? No, 330 does not. 330 is not divisible by 4. So I could divide by 2, but the problem with that is my denominator for 8 over 30 would become 165, and then I would lose my common denominator because 2 does not go into 165. So I'm just going to make common denominators right now. 165 over 330 plus 8 over 330 is 173 over 330. Okay, for number 7, we have 4 digits repeating. So I wrote the first 0 even though it doesn't really do anything. So I told you guys 1 digit repeating, you put that over 9. 2 repeating, you put that over 99. 3 repeating, you put it over 999. So of course 4 repeating, you would put over 9,999. Alright, what can we divide by? 2 doesn't go into both. 3 does go into both, because if you add up the digits of 138, that adds up to 12. 3 goes into 12, so 3 will go into 138. Alright, bottom is easy to divide by 3. The top is 46. Alright, I think that's reduced. Okay, let's see. 46 is 2 times 23. 2 doesn't go into 3,333. 23, I doubt it does, but let's double check. Alright. You can double check by subtracting multiples of 23. So I think an obvious one is 2300. Alright, that will leave 1,033. So now we just have to check, does 23 go into 1,033? I know that 23 times 4 is 92. So 23 times 40 will be 920. Okay, so does 23 go into 133? Well, no, 113. I'll just change that. 113. 23 does not go into 113, so this is reduced. Number 8 looks similar to number 6. So we have 0.5 plus 0.04 with only the 4 repeating. So this is 1/2 plus 1 digit repeating goes over a 9. But to move the decimal spot, we need to add a 0. Alright. So my common denominator, I could reduce 4 over 90 to 2 over 45, but then I would lose my common denominator. So I'm going to leave it as 90. 45 over 90 plus 4 over 90 equals 49 over 90. 49 factored is 7 times 7. 7 goes into 91, so it will not go into 90. So that's our final answer.